Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello students, welcome back again to this TV learning series program. Once again, I'm teacher Patrick, and I'll be taking you through, it's actually the continuation of the previous practical lesson. We are in chemistry, remember? And I hope you still remember the practical lessons that we looked at. The most current previous lesson was about the identification of anions and testing some of the gases. So I hope you still remember the gases that we tested. So we looked at maybe let me just remind you. We looked at the chlorine. So we are able to prepare and test for the chlorine using the litmus paper. The blue litmus paper turned to red, and then it was bleached. So we said chlorine is a bleaching agent. We also tested for sulfur dioxide, and we used potassium permanganate solution. Potassium permanganate is a purple solution. So it turned to colorless. If you are observant, you could have seen that one. We also used potassium dichromate. That potassium dichromate is a yellow-orange solution, and then it turned to green. So those are some of the tests that we carried out, but for those gases. But remember, I said we don't keep gases in the laboratories. So we had to prepare them and then test them. So as a continuation, we are still looking at there are some anions, because that is what we are going to look at. So we also look at the identification of anions. So basically, we'll have to talk about them. There is no need right now to mention them immediately, but we'll talk about them. And then we'll also have to look at the preparation of the carbon dioxide gas. And then that means if we are preparing carbon dioxide, then we'll have to test for the carbon dioxide, and at the same time, that will be the carbonate that will be tested. So right away, without wasting a lot of time, so we'll start with the sulfate ions. These are anions derived from sulfur dioxide. So we have the sulfate ions. So these are anions. This is one of the anions that we have to test for. How do we identify the sulfate ions if it is in a solution? How do you tell that this solution contains sulfate ions? So there are a number of tests, but maybe we will not be able to carry out all the tests, but we will just do the most necessary and important test that is common using common reagents. So right away, let's do the test. So as I mentioned earlier, protection is very important. As long as you are in the lab, you need to protect yourself because we are dealing with acids, and these acids, by the way, for your reminder, these acids are corrosive. They attack the skin. So you have to be very careful. So when you are carrying out some experiments, so that the acids don't, any drop doesn't go onto your skin. So we have the sulfate ions here. So these sulfate ions, we are going to carry out the test to identify the sulfate ions. So as usual, we will have to use just put a very little solution. So I said in a qualitative analysis, we don't need to measurements are not necessary. It is just approximate. So we normally have problems with the students trying to measure, let's say, about 1 cubic centimeter. Then somebody is looking for how to measure 1 cubic centimeter. So we just approximate solutions. So there is no need of measuring, because we are just looking at the quality of the solution. So this is about maybe 3 cubic centimeters or centimeters cubed of the solution containing the sulfate. So remember, these sulfate ions are obtained. We normally use the sulfate, the soluble sulfates to get the solutions. So the soluble sulfates are except, so if we mention about, you remember the solubility rules, that is just senior 2, when we are talking about those solubility rules. The soluble sulfates are only those ones there. Others are insoluble except lead sulfate. And so the lead sulfate is insoluble. Barium sulfate is insoluble. Calcium sulfate is also slightly soluble. So the rest of the sulfates, you can mention them. So we can just still extract that solution. So this one is extracted from those solutions of sulfates except the lead, the barium, and the calcium sulfate, but which I mentioned, calcium sulfate is slightly soluble. So we are going to add, in this one, we are just going to add barium chloride. So we have the barium chloride. So we are adding it to a solution containing sulfate ions. So we add barium chloride. See what happens? That is a precipitate. So when we talk about the precipitate, it is a solid. Precipitates are in form of solids. So the solid is formed. And it is important to identify the color of the precipitate. So this is a white precipitate. You can just take a look at it. So that was barium. I'm just adding barium chloride to a solution containing the sulfate ions. So after adding barium chloride, then we can as well add hydrochloric acid. Later on, I will tell you why we have to add barium hydrochloric acid. This is hydrochloric acid. No change. So this is the white precipitate insoluble in excess acid. So the precipitate persists, doesn't change. That is the sulfate ions. So we can as well mention that what is happening is that we have, so we're starting with the sulfate ions, and the reagent that we are using here is barium chloride. That is what we have used. And then this barium chloride was used together with the hydrochloric acid, which is aqueous. So what happens? So the barium, remember I said the sulfate ions are obtained from any soluble sulfate. You can mention any soluble sulfate. Sodium sulfate, magnesium sulfate, copper sulfate, and many other sulfates, except those ones that we never mentioned, or that we mentioned, which are insoluble. The lead, barium, and calcium. So maybe let's use, if we assume that was magnesium sulfate. That was a solution of magnesium sulfate, not necessarily magnesium sulfate, but I've just assumed if it was magnesium sulfate, because it is soluble, and it contains the sulfate ions. So it reacts with barium chloride. A solution of barium chloride. This is colorless. They are supposed to be colorless. This solution that we have here is colorless, has no color. Barium chloride is also colorless, if you look at it properly. So those are colorless solutions. So you're forming magnesium. So you are forming, this is magnesium chloride, aqueous, plus barium sulfate. Barium sulfate. This is insoluble. So the precipitate, that's why I mentioned it as a solid. I said it is in solid form. So that's why I had to put that in solid form. So basically, when we're writing these reactions in solution form, we don't, in most cases, use all this. This is the molecular equation. So we normally use ionic equation. So the sulfate ions are reacting with the barium ions plus, they are barium ions. So these ones will give the barium sulfate in ionic form. So this is the ionic form. This is the reaction that takes place that gives that white precipitate that we talked about. So this is what takes place. Remember, an ionic equation is only showing the participating ions only. There is no change with the participating ions. So those non-participating ions, they are spectators. We call them spectators, so they are not included. So I said I'll have to mention why we added hydrochloric acid. So we added hydrochloric acid, but it doesn't appear here. So one may ask, why did we have to add hydrochloric acid? And yet this is what was reacting. The barium ions from barium chloride and the sulfate ions coming from this solution of the sulfate ions. So let's try the sulfite ions as well. So this is the sulfate. We have finished. So we have to go to sulfite ions. So the sulfate ions, we are still using the same reagents. Remember, we are not changing the reagents. We are using barium chloride with the hydrochloric acid. So you'll have, pay attention, please, and see what is going to happen. This is the sulfite ions, the solution containing the sulfite ions. Just few drops of it in the solution, as we mentioned. A few drops of it. 2 to 3 cubic centimeters, I think is enough. You don't need to add a lot of it. As I said, in qualitative, you don't need to measure. We're just looking at the quality or the changes that are occurring. See what is happening? The same precipitate is forming. Let's add hydrochloric acid. We're adding hydrochloric acid. Just take a very close look at this axis. So when you take a close look at this solution, it is changing. The precipitate is disappearing in this solution. So the precipitate is disappearing. So it is turning to colorless, slowly disappearing and turning into the colorless solution. So what does that mean? That if we have the sulfate ions, so we are still having the barium ions, they are reacting with the sulfite ions. So these sulfite ions give barium sulfide. So the barium sulfide, this is solid. So we saw the white precipitate that formed first. So that is this barium sulfide, not sulfate. Now this barium sulfide reacts with the reacts with hydrochloric acid. So it reacts with hydrochloric acid to form barium chloride, and then sulfur dioxide and water. So we are not interested in the gas, but the gas was coming up. So what was interested was, we are interested to see the changes that are happening. So in here, it means that why does it have to turn into the colorless? In the first one, this was in excess acid, this remained, this was supposed to be solid. This is barium sulfate persists even when we added excess hydrochloric acid. So I said, why do we have to add hydrochloric acid? So these reagents, the barium chloride and HCl, are used to distinguish between the sulfate ions and the sulfite ions. So when you add the hydrochloric acid, if there was a sulfite, assuming I didn't know that there was a sulfate here, if it was a sulfite here, the precipitate would disappear. So the persistence of the precipitate indicates that the sulfate is formed, because the sulfates do not react with the acids. Now the sulfides, in the second case, where we had the sulfide forming the white precipitate, and then when we added excess hydrochloric acid, the precipitate disappeared. So that means there was another reaction. But with this one, there was no any reaction that was taking place when we added hydrochloric acid. But here, we are having hydrochloric acid as also forming. So that is why this is a colorless solution. So the colorless solution that has been formed is the barium chloride again being regenerated. So that's why the precipitate disappears. So these are the reagents, the common reagents that we can use to distinguish between the sulfate and the sulfite. There are other reagents, probably I can also mention them. You can use barium nitrate. So I'm using the common reagents that are in the lab, the common ones. So barium nitrate with the nitric acid. So still, when you use the same reagents, these reagents can also be used in the same way as we used barium chloride and HCl. The same observations will be made when we use barium nitrate and nitric acid. We'll still get the same observation. So that means if we use barium nitrate and nitric acid and we react it with the sulfate, the white precipitate persists even when we add nitric acid. When it is a sulfide and you add barium nitrate, the precipitate will form of the barium sulfide, and when you add nitric acid, still the precipitate will have to disappear. So that is why I'm saying also these ones can also be used to test for the sulfate and the sulfite ions. So we are just going to continue and then look at the carbonate ions. We are just going to look at the carbonate ions or the carbon dioxide gas. So these ones have the same taste. So we have to prepare carbon dioxide and then test. Well, we are just going to continue and then look at the preparation of carbon dioxide, and then we do the test. I hope you still remember even how the carbon dioxide is prepared. We need the carbonate, as I've mentioned earlier. So this is the carbonate. So we're just going to add this carbonate into this test tube. And then we'll need lime water, solution of lime water. I've mentioned the difference between the lime water. So I already have the solution, the test tube here. So I can have this, I can just add a little lime water solution. That could be enough, lime water. And then what we do is to pass the gas into this lime water. So that means we are having here calcium. We are basically using calcium carbonate reacting with the acid. So this is the acid. So we are adding the acid. So you see what the gas is passing here. This is effervescence, as I've said. Milky solution is forming. So we need to pass more gas. You have to make sure the gas doesn't disappear. So the gas is still there coming. So you see, when I shake, more gas comes out. So that means I'm increasing the rate of the reaction. See what happens with the solution. Just take a close look at that solution, the lime water. It was milky, and then turns back again to colorless. Wow, that's it. So we don't need to continue. So it changes into a colorless solution once again. So you remember we started with the colorless solution, turns milky, and then finally comes back to colorless again. So this is what happens. So we have calcium carbonate is reacting with HCl, and then this produces calcium chloride plus the carbon dioxide gas, and then the water being produced. So the carbon dioxide gas was passed through the lime water, which I have here, which is calcium hydroxide solution, and then forms the calcium carbonate. The white precipitate that forms here, that milky solution that was formed is this calcium carbonate. And then when the excess gas passes through there, so there is water here being formed. So the excess gas passed through the product and then forms calcium hydrogen carbonate. So this is a colorless solution that is formed. So that is the test that we use to confirm the presence of the carbon dioxide as well as the carbonate ions. So I'll just leave you with an exercise that we have. Maybe I'll ask you to take note of this exercise. Part 1A, state the reagents that can be used to distinguish between the sulfate and sulfide ions in the solution. That is 1. 2, we can as well also look at, so that's part A. B, use equations in part A. Number 2, describe the test that can be used to confirm carbon dioxide gas in the lab. I thank you so much for listening and watching. I hope it has been enjoyable, and we'll meet again in the next session. Bye.